soaps the same in making your own insecticidal soap. Most of this information that I have here, I kind of gleaned from Dr. Raymond Cloyd. He is retired horticulturalist with Kansas State University. And so he's got some really good information. So let's step backwards a little bit and talk about insecticidal soaps. An insecticidal soap is really something that is biorational, or essentially what that means is that it's a reduced risk type of an insecticide. It will leave minimal residue on the plant and on the ground. It is also less toxic to us as humans. It is very short-lived in the environment. And it does degrade very rapidly. So you need to make sure that you're aware of these things when you're using insecticidal soap, which means you have to probably use them more frequently than you would if you were using a regular insecticide. So what is actually a soap? A soap is a substance derived from the activity of an alkali, such as a sodium, which is what we're going to find when you take and you have hard soap, like a bar of soap. Or it's got an alkali that's going to be potassium, which is going to be your soft soap, which are going to be your liquids. And those are then a hydroxide on a fat. A lot of chemistry here, and I'm not a big fan of chemistry, but we have to talk about this to understand the differences of the soaps. So a general term for the salts of fatty acids is what really a soap is going to be. The fats then are a blend of particular fatty acid chain lengths, and they can come from fish, they can come from whale, vegetable, corn, coconut, linseed, and soybean. All of those can be oils that are added to the making of soap, which actually creates those fatty acids. So the oil is going to be those fatty acids. So when we're looking at this, the active ingredient in a purchased over-the-counter, EPA regulated insecticidal soap is going to have as an active ingredient potassium salts of fatty acid. And as you can see here on this particular picture of one that is purchased over the counter, it has potassium salts of fatty acids. And so 49.52% of the contents of this particular container is going to be the potassium salts of fatty acids. And that means it's going to have the soap in it. Most of these are going to be used on soft-bodied insects and on mites, which include the aphid scales, mealybugs, thrips, whiteflies, the two-spotted spider mite, and the Tetranicus urticae. If your Latin is much better than mine, go ahead and try to pronounce it. It's really good on nymphs, which is going to be the very small beginning stages of some of the different insects. It's also good on larvae, the caterpillar, the larva, as well as crawlers. The crawlers are going to be associated with mites. And so the insecticidal soaps are good for those. So just as a kind of a review, but the fatty acids is what is of interest. So the mode of action for the insecticidal soaps, it's not really well documented with a bunch of research. There is some, but they haven't done much. They can't really tell. What they actually believe is 3 different modes of action. Modes of actions mean how does it actually cause damage to those insects. So the mode of action, those fatty acids are going to penetrate through the insect's outer covering, the shell or the cuticle of that particular insect. And it's going to disrupt those cells, could burst those cells, making them open to the air, the environment, and potentially drying out the insect where it will actually dehydrate. They also think it could be an insect growth regulator that might be part of the chain of those fatty acids that will actually inhibit the growth when an insect goes through complete metamorphosis. So it will have an egg, it'll move into a larva or a caterpillar, it will become some sort of a chrysalis, and then it will come out as a caterpillar or a butterfly. And so during that metamorphosis stage, it actually inhibits the growth of that next phase of the insect. They also think that it could be that it blocks the spiracles of an insect. So here we see a larva, an insect larva, and the circle here, and if you look at all of those are called spiracles. Spiracles are actually how an insect is going to breathe, because it doesn't have a nose like us with humans on its face, but this is how an insect will breathe. So if you cover the insect with the insecticidal soap and you cover it, which we always say, make sure you cover the insect completely, because they're not sure which of these three different methods are going to be the ones that mode of action that's going to cause damage to that insect. So you want to cover all of those spiracles if at all possible. So the real question then boils down to is, are all fatty acids the same? And the answer is no. More insect and mite activity occur when composed of long chain fatty acids. So they have to have a chain of 10 to 18 carbon chains. That's when they actually affect the insect itself. Soaps with a shorter chain of fatty acids, 9 carbon chains or less, are less active as an insecticide. So again, depending upon the fatty acids that are in the soap will make a difference on whether it's a stronger effect on the insects or a lesser effect on the insects. So the type of fatty acid chain, as far as each soap, we don't know what they are, because they are not a registered EPA product. Soaps, our bar soaps and our liquid soaps, are not intended by the manufacturers to be used as an insecticide. So EPA doesn't regulate them. So therefore, EPA does not know what kind of fatty acid chains each of those different soaps contain. So the ones that we see here are the ones that are most prominently used for insecticidal soaps: the Palmolive, Ivory, Joy, and Dawn. There are a few others that are listed in that publication from Dr. Cloyd, and each of these will have a different type and effect on different insects. It's really interesting. And what people predominantly believe is that Dawn is the best soap to use for insecticidal soap. So we have to also be careful with when we're talking about insecticidal soaps. Again, the soaps are not registered with EPA. So you have to remember that soaps are designed to cut grease. They're not designed to kill insects, if you think of our dishwashing soaps. We have to also know and realize that the type of fatty acid chain is unknown to us when we're using it as an insecticide. We have to remember that some of those fatty acids, depending upon if they're a long chain or a short chain, can actually solidify. It's not that they become like a hard soap, but they actually will solidify in a chemical fashion when we're using hard water. And then they're becoming less effective as those fatty acids might chemically solidify. So we have to be careful when we're using the insecticidal soaps. We have to understand that if there is a waxy leaf type of a plant, that a lot of times, because remember, soaps cut grease, that wax could be affected because of that action of the cutting of the grease. So be careful when you're applying to leaves that are waxy. Plants with pubescent leaves, pubescent means hairy leaves, may be more susceptible to damage than even the waxy leaf types of plants. And so again, these types of insecticidal soaps can cause phytotoxicity, and phytotoxicity means that they're just going to cause some sort of a damage to the plant of some sort due to environmental conditions. So it might be very warm out, it might be really sunny out, and there's not a lot of research of understanding why there might be damage to some of these different plants. And then here is one, and I did a deep search trying to find a plant that had damage from a homemade insecticidal soap, and I believe that this is one of those that had some damage from that. It came from University of Nebraska, Lincoln.